Yeah, well, thank you for the kind introduction, Guru. So today, I wanted to talk a bit about just a holistic and more demand side view of Edge. Now, for MobiledgeX, it's somewhat cheating to call us a startup, and that we're roughly about 22 months old, so nearly 2 years old, but we're a wholly owned subsidiary of Deutsche Telekom. So the founder of the company was DT, out of Germany. And so, for example, there's some other DT speakers from DT proper, that are present here at the conference, largely talking about the infrastructure transformations that have been present. Hey there. Now, for MobiledgeX, a lot of this view then was reflected in some of the things I want to accomplish today, which is the demand side. So we're going and doing these infrastructure transformations. SDN's a given, NFVI's a given. A lot of these things that we've been talking about the last few years are now actually sort of occurring. If we begin to have that type of infrastructure present within certain locations, then that sort of question of who is it fundamentally for, what's the best experience for how it's consumed by them, why now, and then are there any sort of common characteristics of these use cases that can start to be done in discrete services that are present within this parts of the infrastructure. The other thing I wanted to cover really was what I think is a pretty simple difference between edge and quote-unquote cloud. It's a bit of the meta concept. And then, of course, we'll talk about what's occurring anyways and how do we take advantage of that. Oddly enough, we'll be going through this list backwards, okay? In that. So in the edge conversation, what I find is no matter who you ask, what is edge, they always have an answer, and then depending on who they are, that answer is very specific to themselves. So, if you go to a chip maker and you say, what is edge, you hear a certain answer as to what edge is, but it's, of course, an answer from their perspective. If you go to a mobile operator and you ask, what is edge, you hear a very mobile operator-based definition, et cetera, like that. The reality is that the overall edge ecosystem does involve everybody. So cloud providers themselves, the underlying technology providers in that, device makers, people that are putting engines, frameworks, applications on these types of devices. And then edge becomes a little bit different from enterprise IT and typical sort of cloud deployments in that you do start hitting a boundary of a regulatory regime that's not present in large public clouds. Because much of what you talk about edge and a lot of the interest around edge is around things that are wireless, cordless, hands-free, right? So either drones that are moving on their own, cars that are moving on their own, net new devices that have to coordinate, people actually playing a game together on mobile devices, people having a social AR experience. I mean, every sort of use case you look at, most of them tend to be wireless, cordless, hands-free. Being wireless, cordless, hands-free means you're going to be consuming spectrum, and spectrum is a government-owned and a government-regulated asset class that's typically leased to other people. And so the second you head into that, you do head into a certain sort of regulatory regime. And depending on what different countries are doing with the mobile networks themselves and how access is happening and how the sort of spectral regime and how 5G, 6G, 7G, 8G is going to basically happen, will determine in many ways how edge will happen in that country as well. So we do actually have to be aware, sort of that. Now, lots of bullet points in the next one, but relatively simple. And it is from a meta perspective, and you can think of either a metadata perspective or just meta, okay? And that is that typically when we look at the simplest definition of quote-unquote clouds, clouds are highly accessible, industrialized infrastructure, at the very basis of it. And these two criteria for infrastructure did revolutionize quite a bit So being highly accessible impacts every other functional requirement of the infrastructure, right? How it's actually maintained, how it's actually secured, and so on like that. The idea that you decide that you're going to have multi-tenancy and a whole bunch of different people basically in the same footprint puts a lot of requirements on a lot of other requirements, in that. And the industrialization of it is very much this type of component-based supply chain type thinking that was put in infrastructure. So the idea that you're actually going to go, and the second you're actually having a different ratio of memory to CPU cores, you're going to upgrade those boards, and you want to do CPUs here, and you're going to sort of minimize these systems. You've basically headed into, a lot of that in there. And the fundamental question for me in cloud, which is the second bullet point, is always that, how do I physically and logically design a scalable, cost-effective data center independent of knowing what you're going to do with it? Now, there's been a lot of ways that problem in cloud has been reduced from a dimensionality standpoint. So for example, like fixed instance sizes. You're only going to get a 4 gig instance, 8 gig instance, 16 gig instance. You're not going to let people dial things sort of up and down, in there. Now, when we look at edge, of course, you'll hear edge cloud, distributed cloud, cloud edges, cloudlets. You'll hear all the same basic terms. Architecturally, it's the same. Okay, so all the cloud architectures that you see basically feed into sort of edge architectures. There are some little differences, and some that have big implications. So first, of course, clouds tend to exist in the hundreds. Edge need to exist in the hundreds of thousands. We have examples of things that exist in the hundreds of thousands today. That's typically sort of base station and access site deployments, in that. So you're typically looking at hundreds of thousands of base station deployments in a country like the United States, talking to, sort of another sort of tier down of there. Clouds by definition, and this is literally even the NIST definition that was finally sort of sat upon, clouds are meant to give the impression of infinite resources and scale. So if you basically show up and you need something, you're going to get it. If you need to scale it, you're going to be able to scale it. And there's always going to be sort of this constant sort of growth within this big mega thing. Edges are always going to be finite in size. And there's always then going to be a scarcity model within the consumption of these points of presence. And that's not going to change. The idea that we're going to build hundreds of thousands or millions of gigawatt-sized facilities is just not needed, from that perspective. So there's always going to be in there. Now, then there ends up being a couple somewhat subtle things in the following four here that actually have pretty dramatic implications, in my opinion, when you let them settle a bit. So the first one really is around the mobility of the workload itself. And you could think of this as being literally differences between things like lambda and pi calculus sort of approaches to language or the like. But what we really have is we have the transition where we used to have a client that sat somewhere talking to a server that sat somewhere, and they were static in that. We've already seen the revolution that occurred when the clients became completely mobile and when we had a known GPS location and location services present on that client, right? That's the smartphone we all carry around. But the back ends those phones talk to tend to still be static and present in some location, right? The idea that those back ends have the same mobility as the devices, and they actually move together as they sort of move around, is just a very simple mobility concept that's introduced into a back end, right? And this can range from VNF concepts all the way up to application back end. So even the idea that if you're roaming on your phone and you show up in another country and your native country's operator deploys a packet core with the other operator in that sort of country to serve you, even that type of mobility from a VNF perspective requires more thinking and work than I think we realize. But for me, it's as simple as static client, static server becomes mobile client, static server becomes mobile, mobile. Static, static, mobile, mobile type in that. And the reality is that true workload mobility is still an interesting problem to solve. The other one is that an ops team is not going to pick a given edge location and push something in. Devices and their applications will trigger the consumption of edge. So a device showing up and an application showing up on a device is going to trigger a whole series of things to automatically happen. It's not going to be a statically allocated type architecture. It's not going to be someone deciding which availability zone they're going to stick something in. It's in fact going to be the sea of devices moving around that's going to be driving the provisioning sort of model in there. The other thing being, as we said, edge workloads have a highly precise and accurate GPS location. You know, we have abstractions in the cloud space of here's my region, here's my availability zones, here's what availability zones I use. You might know which part of a country it's in. You know, you might know which state it's in. You might be able to sort of guess around things. But having a highly precise and accurate GPS location and having a known network topology is purposefully obfuscated away and always will be, you know, in sort of the cloud space. And then the other one is that edge workloads have to have an inherent understanding of economics and sovereignty, you know, sort of in that. So, in conclusion, very distributed versus a bit more centralized, finite versus infinite, a federated model versus what tends to be a proprietary model, a much more declarative deployment versus an imperative deployment, sort of in that. And there's some basic sort of metadata differences there in cloud. It's funny, I'm looking at the thing turning down. I said, how did it get to be 7:05? But it's 19 minutes. Now, if you look at the complete edge landscape, there's a lot of edges that people talk about. So there are people that make devices, you know, number one there, that talk about I'm going to have a bunch of peer-to-peer connected devices and all my devices are an edge. All my cars sit there, that's the edge. You know, my set-top boxes, that's the sort of edge. And as you head into set-top boxes, you head into a bit more of what you'd call an on-premise edge. So you have some device that's basically in there. We have things in the networks themselves, and then I would say, you know, basically like, you know, the edge of the internet. Now, to use, you know, approximate numbers from, say, a country like Germany, where we've been deploying these things, is you'll have, say, AWS, Microsoft Azure, Google Cloud, you know, have about 9 availability zones present in one city called Frankfurt in Germany. You know, that, of course, then plugs into a transport backbone that tends to be in Frankfurt, Berlin, and Hamburg and sort of covers the major cities. And then once you transition into a mobile network, then you're hitting on the order of about 10 core sites, roughly 1,000 access sites, and then about 40,000 base stations. And then a given operator, you're touching about, say, 20 million devices, you know, sort of on the other end. And there may be things that are in between as well. You know, 2 million Wi-Fi devices, 2 million set-top boxes, you know, things like that. And when you begin to start thinking about that whole infrastructure footprint of 9 cloud availability zones, transport hubs, 10 mobile core sites, 1,000 access sites, you know, 1 million sort of deployed on-premise things, you know, 10 million sort of deployed sort of devices in that, then the question is not so much how do we expose one given part of it. The question really is how do we have a programming and a deployment model that covers that whole distributed system, right? So the point I'd like to make on this is 2 parts. The first one is if we set the edge word aside and we say what part of the overall infrastructure has not been exposed for consumption, question mark. Like which one does not have a clear means of distribution and a way to economically engage? Well, there's a clear means of distribution and a way to engage on devices. So you put things in the App Store and it shows up on devices. There's a clear way to engage and deploy on clouds. The footprint that sits in the middle, that's largely with operators, has not had a clear means of distribution and a clear way to economically engage. So one part of the problem is how do we have a clear means of distribution and a way to economically engage in that part of the footprint. That's phase 1 of the problem. Phase 2 of the problem then is how do we have a complete holistic view of the whole thing, from device to network to cloud, because the reality is there would be bits of software on the device, in the network, on a cloud, end to end. And the issue is not so much how do I figure out how to put something in this edge. The issue is basically how do I think of the whole thing as a much larger distributed system, you know, sort of in there. So 2 parts to that. And of course, a lot of the things that are occurring, you know, in the operator space is, you know, how to expose things that are, you know, a bit more there. Now we have strengths and weaknesses of each. and we don't need to go too much into these, but I'll home in just on the network edge part of it, so the third one down. And of course, the main sort of weakness there, not broadly available, and it's very dependent on telecom transformation plans, sort of in that, right? And the like. Okay, so that's a bit about edge in there. Now I want to talk in the latter part here about devices and some use case domains. So we know, as we said already, wireless, cordless, hands-free tends to be a pretty preferred type of experience, okay? Now, when you think about, and I don't, well, I'll pretend I have a phone in my hand. But we know, for example, that the smartphones that we carry around are probably the most personal of personal computers we've had. Like we have this on our body more than we've had a laptop on our body, and they're very powerful devices. So a smartphone that you go and buy today is more powerful than a laptop from 4 or 5 years ago, and that sort of continues. It's a very powerful device. It also has more sensors than we typically have in other personal computers, and a lot more things that can basically be instrumented in it. We still, though, consume it one-to-one, and we still spend a lot of our time looking down at it like this. And of course, the looking down at it like this is enough of a problem that even children are starting to grow these bone spurs on the back of their heads and skull and the like. But we consume it like this. So a lot of it has been video, a bit of messaging, and a little bit of voice. That's what we do with these smartphones. And a lot of it has been around the consumption of video. Now, when you think about that, we consume video. We tend to basically consume the same thing, and it takes over the entire screen on the device. Now, the next step is pretty simple, is if you start having experiences that require you to first lift the device up, right? So you hold it up here now, and you're doing that because of where the camera is on the device. And so initially we do it just to take a picture, just to take a video ourselves, and then the picture goes up and the video goes up. That's become super popular. I mean, the majority of what goes up on YouTube and Instagram and Facebook and everything else is somebody holding their phone up and taking a picture or a video. So that's the first thing. So the big thing we have to deal with then, even from an operator perspective, was step one was dealing with all the video downloading that was happening, then all the video streaming that was happening, then all the video uploading that had started to happen, and then all the video streaming that started to happen. And of course, that next step of just getting to the video streaming up is a lot of effort, sort of in that. But then you go the next step, where now we're still going to do, yes, content delivery, but the content's not going to take over the entire screen of the device. Right? The content is going to be like just a character out of a movie, where that character comes in and the background's provided by the video camera on the device. And you can call that AR, MR, sort of whatever, but that's all it is. You have a digital asset coming in that actually then has to be mapped into that camera that's present there. But the behavior of that is personalized and interactive to that viewer. And then if you go the next step, where there's a group of people actually doing this, and all that basically has to be coordinated in there. And I think what you'll find is roughly in every sort of next generation use case and everything else like that, you have a lot of these common characteristics of people will start doing here. We'll actually have a video feed on the device being combined with a digital asset. It'll be personalized. It'll be interactive. Then it'll be social. Then it'll be collaborative, not terribly different than before. And the second you start holding your phone up like this on a regular basis, you also begin to realize the field of view is very small, and your arm gets tired holding it up. Now, the more and more we do this, the more and more as consumers will want that experience to move to glasses, to move to headsets, to move to another display. And then once you start having that, now you have a world that's a lot more than just your smartphone. So are all these going to be tethered to a smartphone? Are they going to be independent cellular devices? How's that going to sort of basically work? And so a lot of these new experiences that are coming around that are very pervasive and very immersive should be helped and require us to do more from the mobile operator side to support those types of things. Now, that's the bottom left. So there's a lot of these pervasive and immersive experiences that are showing up. There are also a lot of just good, solid, basic ones. Mobile data thinning is one that's definitely sort of an edge workload. There's security, compliance, privacy concepts around data sovereignty. Mobile gaming is, of course, a big sort of consumer one that's got these common elements. And then autonomy of these devices is a whole domain. And what I mean by that is, again, we hold our smartphones like this. We provide the smartphone with its mobility, right? And then the second we start holding it up where we have the physical video, video of the physical world combining with some digital asset that's personalized for me that's then moving to multiple displays, then we do this. But if you take your hand away from the smartphone and it flies off somewhere now, it's just a drone, right? And if you sit in it and it takes you somewhere, it's a car. But this idea that then these devices start actually having mobility that they're responsible for means that autonomy is just a first cousin of mobility. And so, you know, mobile networks can become autonomous networks. These things will actually have to play a role in the coordination of these devices, how these devices are managed, how they interact with one another, you know, and sort of the like. And so that ends up being a whole sort of domain area as well. Now, one thing you will notice is that this doesn't say latency, 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 latency in it. Latency, of course, is a component of these things, just like anything else is. But we tend to sort of work right now, you know, largely around, you know, these six sort of areas. Now, the final two things before Q&A is just, you know, the way we've ended up managing that is, you know, the bottom, you know, the truth is that most of the cloud transformations that are occurring in the operator space, you know, if you look at what it is, it's fundamentally going to be the presence of a Kubernetes API present in an access site, I mean, at the end of the day. And so some of the issues then is how to just do a distributed sort of federated sort of issue in that. Very sort of standard sort of thinking of controller resource management. The distributed matching engine comes from just trading concepts. So most high-frequency trading systems have a distributed matching engine in them. So we just basically look at trading, and then we do sort of on-device software. But when you look at this, is end-to-end, the way we've been addressing this in the operator space is we put some software on the device, we put some software in the network, we put some software on a cloud. There's effectively a two-tiered controller structure and sort of resource management in it. And then there's basically a trading engine sitting in the middle of this. And then, of course, the overall goal is to have a trusted edge, or safer edge, if you will, with trusted users, trusted applications, and the sort of network itself. You know, in that edge, at the very least, needs to be and should be more secure and more privacy aware than the overall internet has been. So when we start thinking about verified connections, verified applications, verified users, how these whole things basically work together, you know, then issues of spoofing, masquerading, who's actually on the device, who's consuming the content, how does DRM happen? There are a lot of consequences that flow, you know, out of this. And of course, part of this consideration is that mobile networks themselves actually tend to be large country-specific private networks in between the internet and a device. That's the reality of them. And when we start putting things in there, then we should inherit those realities, right? And there's an opportunity then to have a security profile, privacy profile, even the ability to manage how consent moves around and what people are sort of, you know, allowed to do that hasn't been sort of possible before. And with that, we're done. Thank you.
Okay, so I guess we have time for questions. So,
or not, it's fine.
So Jason, let me start with one question. So you said, you know, the way you're thinking about edge is you're not thinking about edge in isolation. You have to think about doing this distributed programming, distributed processing, because these are device, edge, maybe another cloud, and then another cloud, right? The public cloud.
That's right.
So traditionally, we have not done really well in enabling application developers to do distributed programming.
That's
and
right.
so how is this going to happen that, typically you want application programmers to bring all these applications on this kind of an infrastructure.
Yeah.
And if success of edge depends on apps developer to be able to do this kind of a distributed programming, doesn't that pose a serious problem?
Well, I mean, that's the, so in my opinion, any successful cloud or networked service is a service that solves a hard distributed system problem for developers and abstracts it in a way that's very easy to consume. So if you even look at like the rise of, say, Amazon S3 as being one of the first really sort of exponentially taking off cloud services, as an object store, that actually solved a hard distributed system problem for developers, in that a lot of web developers didn't actually know how to store a lot of assets on hard drives. Right, and so you're correct in that. So the basic answer is yes. Any successful edge service, just like any successful cloud service, has to solve that problem. The how, it's going to depend on the service and sort of what the interface is and everything else. I mean, we're trying to make it where, if you stop and you think, you can either have a choice where, even within most companies, you have people that are doing an application on a device and you have the back-end team working together, right? And then the question really is the back-end team going to make some decision to push something in an edge, or is the device team going to get some very simple interfaces on the device that triggers the use of it? And we think that the guys that are doing the applications on the device and doing the devices themselves, need a really sort of simple abstractions to actually consume, where what we're doing on the back end is solving some of those hard distributed system problems for them on their behalf. And not, for example, giving access to typical sort of DevOps teams to just sort of push whatever they want in from sort of that perspective and pick a given site. You want it to be actually much more dynamic and distributed. So, but that is the core of the problem. So anytime you do a cloud service and edge, like whatever, if you want to do a developer-facing service, it's only going to be successful if it's solving a distributed system problem for them.
Okay.
Yeah.
Hello, Jason. Thank you so much for the presentation. I do have a few questions for you. From what I understood, the edge border is basically variable depending on the application, on that stratum that you specified. If you could, please give me some details on how you see IoT security fitting into that.
Yeah.
And also, imagine just what you mentioned, the S3 Amazon store, holding someone's photos from their phone, which they don't have locally.
Yeah.
What happens when there's no 5G coverage? What happens when there's no Wi-Fi coverage? And all of a sudden, as you mentioned, in a roaming scenario, we're in a 3G coverage.
Yeah.
Those are my questions.
Okay. Okay, great. So on the first one, when you look at a lot of the IoT security issues is, within the mobile networks themselves, we have mechanisms for, like a guaranteed delivery, guaranteed supply chain of like software updates. So how you actually connect to a smartphone, update a smartphone, how do you actually do sort of software lifecycle management on a cellular connected device? There are systems in place there that are separate from, they don't necessarily sit on the internet, they're really meant to do that. So even when you start looking at device management, software lifecycle management, application lifecycle management, that's meant to actually have a guaranteed and completely, in a high integrity sort of chain of custody around software assets that move across IoT devices. At the very least, using these types of channels as a control plane. We have just some simple use cases popping out of that. So a lot of it's just around securing the device itself, securing software updates to the device, securing data coming off the device, and just doing chain of custody. Now that relates somewhat to, even if you think about use cases of like verified content uploads. So you can actually sit down and say someone here pulls out their phone, takes a video of the phone, uploads it to a YouTube, a Facebook. How do you actually have sort of a guaranteed chain of custody and sort of a guaranteed idea that that content, was generated by that end user and is basically okay and so on like that. there's a lot of metadata that comes along the way that we could be exposing up better to the YouTubes and Facebooks of the world to help with those issues. So it's a very similar thing in the sense of we know where the device is. We have metadata around where the video was created. We know whether someone biometrically logged into the device or not. You can actually bring the video up one level, and we could go ahead and, present in the Edge site, compare it to mapping data and other sort of things around there to see if there's actually landmark things in the background. And there's other ways of sort of that we can help with that overall issue. Now, I think when you look at this, it's meant to be multi-access. So 5G is not a requirement, and so the idea being, as one goes from a 3G to a 4G to a 5G to a 6G to a 7G to an 8G, things get better, but there's not like a point when all of a sudden something becomes possible that isn't possible today. And as we actually converge wireless and wireline, things get better, but it's not like all of a sudden something becomes possible today. So there's just a lot of basics on the operator side of how do we expose a distribution and deployment mechanism to third parties, and how do we actually deploy a common model for them to economically engage, and how do we sort of go and do this. That's very independent of access.
Okay, so I guess maybe let me ask you one more last question and some more speculation, see whether you're willing to speculate some. So in this edge, of course, telcos are wanting to, and you are part of that to some extent, wanting to own and do this. Yeah. There may be cloud providers that are wanting to do this. There are another class of people that are wanting to do it.
Yeah.
So what do you think is going to, who has the best chance of?
Well, so I think, we have two dominant, the quick answer to this is we have two dominant models in the world that have sort of won out. Model number one is sort of this cloud model of there's going to be 1, 2, 3 people, and one's going to really dominate, and one's going to come in pretty second, one's going to come in a distance third, right? But you have a dominant technology provider that's out there that's global. We'll call that the cloud model. On the other side, you have the model of mobile networks. There is no dominant global mobile network provider because it doesn't work that way. It's anchored in an asset class called spectrum that's country specific. And so in the mobile networks, anywhere you go in the world, your smartphone just works. And that's because that's a completely federated system that's interoperable across, 190-ish countries and every sort of mobile operator in the space. Now the edge sits in between those two, okay? Now there are aspects that edge will have to inherit from cloud, and cloud has to participate in. And there are aspects from the mobile network model that edge will actually, sort of inherit and edge has to participate in. So I think in the case of edge, it's not going to be cloud versus telco. These two entities have to work together to actually make this possible for the betterment and on behalf of the people that actually need to consume it. And the reality is there will be aspects of it that take on the cloud model, and there'll be aspects of it that have to take on the characteristics of mobile network deployments.
Okay.
So there won't be a winner takes all on edge.
Okay, good to know that. Okay, thank you, Jason.
Thank you.